Hey, welcome to what is most likely your first homework assignment of seventh grade math. Um, Today we're going to be doing Desmos Unit 1, Lesson 1 practice set, starting right off at the beginning. Um, Sometimes when we do these Desmos homeworks, I'll assign them online. Sometimes I'll assign them in your book. And then sometimes some of the videos that I've recorded for these assignments will be online, but maybe you got assigned it in the book. And sometimes I'll use the book or a paper version, but you got assigned it online. It doesn't really matter. The questions are the same in either one. They might be formatted slightly different, like, instead of all being on a page or on different screens of an online thing or whatever, but in the end, it's all the same questions. In some of the videos, I will do the entire assignment with you, especially if I think it's a more challenging one. And in some of the videos, I will maybe get you started on questions and then leave them for you to finish, or maybe only do some of the questions and leave other ones for you to finish. Um, you know, just follow along the best you can. I really encourage you to actually watch and listen and follow along with the videos because I'm going to re-explain and sort of like re-teach the things that we've been learning in class. Obviously, you could just skip ahead and pause to where you see the answers and copy them, and there's not a whole lot I could do about that. But you would be cheating yourself out of some learning if you were to do it that way. So you got to make the right decision for yourself. All right, with that being said, let's get started. These Desmos practice sets, they like to start with warm-ups often, and the warm-ups are usually connected to what it is that we're trying to learn or what we want to learn, but it might not be extremely obvious right away how they're connected. So for example, these ones, they all have some number times blank equals some other number. 4 times something equals 32, 6 times something equals 9. And it's our job to figure out what goes in the blank. Well, what they're trying to remind you of is something that I hope you learned in 5th or 6th grade, is that, like, let me use a really simple example, maybe like 2, 3, and 6. 2 times 3 equals 6. And you can reverse that. You could take the number over here on this side of the equal sign and divide it by either one of these two numbers, the 2 or the 3. So let's do 6 divided by 2, and you will get the one that you didn't use. This time we got the 3. If we had chosen to divide by the 3, 6 divided by 3, we would have gotten the 2. So multiplication and division work in reverse of each other in this way. And that will be important for a certain concept in this scale drawing stuff that we're talking about in class right now. So in these questions, if you want to fill in the blank, just take the number on the right side of the equal sign and divide it by the number they gave you, and you will figure out what number goes there in the blank. So for example, 15 divided by 5, kind of an ugly division symbol there, but whatever. I believe it's 3, right? So 5 times 3 equals 15. So I'm going to leave this one for you to do. These two are a little bit more challenging because they don't come out to nice whole numbers. They come out to fractions. So I'm going to do one of them with you, leave the other one for you to do. Let's do the 3 divided by 12. Now you could write it just like I did this one, 3 divided by 12. And if you punch that into a calculator, you'll get a nice decimal answer that you put in there, be fine. But I like it when students are willing to work with fractions. And so rather than writing it as 3 divided by 12 with a division symbol, let's do it as 3 divided by 12 as a fraction. That fraction bar means divided by. So this is 3/12, but it's also 3 divided by 12. And if we use our fraction simplification skills, noticing that I could divide the top and the bottom of this fraction by 3, because 3 goes into 3, and 3 goes into 12, we get 1/4. If you punch this into a calculator, if you did 3 divided by 12, you got 0.25, right? 0.25, 1/4, the same thing. So both of those are acceptable answers for this blank here. And so you could do the same thing with this one. But one thing that is tough about this one is if you punch 9 divided by 6 into a calculator, you're going to get a repeater decimal. You're going to get 1.333333333, right? And we try to not use those when we can. They're ugly. They're not ideal. And so I'm going to challenge you to see if you can do this one with fraction way rather than decimal way. All right, let's move on. So next it says circle all of the figures that are scaled copies of the original. Here's our original. Looks like the letter A. I want to know about its dimensions. That's its height, its length, width, whatever you want to say, right? How big is it around? Well, that's the perimeter. Okay, so let's count some boxes. It is from the bottom point here in the corner to like its highest point, the tippy top there, it's 2 boxes up, right? 1, 2. And then in its widest point, from this bottom corner here to this bottom corner here, it is 1, 2 boxes wide. So the A isn't taking up the whole 2 boxes up, 2 boxes wide area, zone, whatever you want to say, but like its maximum height and its maximum width are 2 boxes by 2 boxes. So it's the same height as it is wide. So any scale copy of it also needs to be the same width as it is tall. That's how I know that it has the same proportions, or that there will be a scale factor between the original and this supposed copy. If it's like taller than it is wide, then that means it got stretched out this way and it's not to scale, as we would say. And if it's wider than it is tall, then I know it's not a scale copy. We would say it's disproportionately wide, or it's not to scale. So I'm going to pick, there's 2 scale copies in here. I didn't mean to just point at them, but I just pointed at them if you caught that. I'm gonna circle one of them. I'll leave the other one for you to circle. Hopefully you see which 2 are not scale copies. So I would say this one's a scale copy, because if I count its width from bottom point to bottom point, it's 1 box. And if I count its height from top to bottom, it's 1 box. So it's 1 by 1, which is proportional to something that's 2 by 2. So circle the other one in there. Hopefully you see that this one is too tall. It's 3 boxes tall while only being 2 boxes wide. So this one got stretched this way. And then that other one is kind of planted, right? All right, so 1.2 says, choose one figure that is not a scaled copy. Explain how you know. Well, I kind of just said, right? I just talked about 2 of these, which ones are not the scaled copies. The one that I would prefer you to answer is talk about this one. So this could look, if you're just like skipping through the video and trying to find the answers, this could be very misleading, because I've circled 2 things here. So you might think, oh, these are the scaled copies, right? Circle the ones that are scaled copies. But I didn't circle 2 that were scaled copies. You were supposed to circle them both. And this one, I'm going to put an arrow here that says not scale. And I would like for you to write an answer here that says something along the lines of figure 3 is blank boxes tall and blank boxes wide, which is, I don't know, I guess we could say taller, skinnier, stretched vertically. As we get better at this and we learn more and more, we'll describe this more mathematically and with some ratios and some numbers. But since this is the first lesson, we can just use descriptor words. Tall, stretched, skinny, whatever, is taller than it should be. All right. But when it comes time to quiz time, though, I'll need you to do it a little bit more mathematically than that. We're just getting started. All right. The next part says, on the grid, draw a different scaled copy of the original letter A. So the original letter A was 2 boxes tall, 2 boxes wide. So same height as it is width. As long as we keep that relationship between its height and its width the same, then we'll have a scaled figure. So we could make it 10 boxes tall, 10 boxes wide, 80 boxes tall, 80 boxes wide, 1.5 boxes tall, 1.5 boxes wide, whatever, as long as it's the same width as it is height. When I first looked at this, I thought, oh, it'd be really easy. Let's do 5 by 5. Because see how the grid is broken into like 5 by 5 sections. Like these lines are a little bit bolder. But look, we already got a 5 by 5 here. If you notice that figure 4 is a scale figure in the first part, it's 5 boxes wide and 5 boxes tall. And they want us to do a different one. So I'm going to do 10 by 10. 10 by 10 would be 10 boxes tall. That's 2 of these like bigger sections. And 10 boxes wide. That's also 2 of these bigger sections. So if I make a dot here for like the bottom of one leg of the A, another dot here for a bottom of the other leg, the top of the center of the A should be right there at the top middle. So here's the outer part of the A. I'm going to use my ruler to make it look nice. When you draw stuff with a ruler, don't put your ruler exactly on where you want the ruler to be or where you want your line to be. Make sure you're back that like 1 millimeter from it to give your pen or your pencil room to sit so that your line actually winds up where you want it. If you put your ruler right where you actually want your line, your pencil won't have space and you'll be off by a little bit. Okay, so now we got to think about where does the crossbar of the A go? If we look in the original figure, the crossbar of the A is right on the middle line that's like if you're counting the boxes and go 1, 2, it's right on that line of the 1, which is right in the middle of its up and down vertical dimension, right? So we want to do the same thing. We want our crossbar to be right in the middle of the A, which since this is 10 boxes, that would be right on the 5th box, which is the bolder line right here. So our crossbar needs to go from here to here. And I would say that's a pretty good 10 by 10 scale figure. We would say this one, we made it with a scale factor of 5 because the original drawing was 2 boxes tall, 2 boxes wide. And we made one that's 10 by 10. 2 times 5 is 10. So that 5, that's our scale factor. All right, the last piece of this, usually each year I go over this part in class a little bit and give some instructions before I assign this, but sometimes I forget or, the class period ends before I get a chance to or whatever. So hopefully I gave you instructions that are something like this. If I didn't give you these instructions, you can go ahead and follow these and it'll be fine. You'll get full credit, even if I didn't say them in class. Or if I said something different in class, try to follow whatever it was I said in class. But even still, if you do it like this, you probably still be fine. So you're supposed to write your name in this original area. But one of the things I hate about this particular assignment is that that's not fair because I've had students whose name is literally one letter. A singular letter is their name. And I've had students whose names are 15 letters long or whatever. And so that's not fair if somebody has to do 15 times as much work, right? So what I usually say is write at least 4 letters. If your name's shorter than 4 letters, then use some of the letters from your middle or your last name or whatever. And if your name's longer than 4 letters, then you can stop at 4 if you want, or do your whole name if you want, I guess. But 4 letters is like the requirement. Now, if it were me, I would want to make my life easy and like make it so that the boxes make everything I'm doing really easy. So my first name's Robert. So I'm going to do ROBE, robe. Those are 4 letters. I'm actually not going to do all that. I'm only going to do 1 letter as an example. I would use the outer grid line for the side of my R. And so it's kind of hard to see, but I'm highlighting that in this sort of orangish pink color I got here. And then I got to make the curvy part of my R, right? Well, what if I do it so that the curve is way over there on the fifth box away, right? That next bold line, and then comes back here, right in the center. And then I'm going to make the leg of the R go from here right where that line met to the bottom corner here. Now, this isn't how I would normally draw an R, right? That's sort of a strange R, but it made my life really easy because now if I just want to double everything for this R, because they notice they gave me double the height space here, then now I'm just, instead of my R being one 5-box section wide, it'll be 2 5-box sections wide. So instead of 5 little boxes, it'll be 10 boxes wide. And instead of being 10 boxes tall, right, 2 big sections, it'll be 4 big sections tall, 1, 2, 3, 4, or 20 boxes tall. And so it makes it really easy to just double everything. I'm going to make this really long side of my R here. Right, I'm not drawing exactly on the line because I want you to be able to see my color. Okay, and then the point of like this curve of the R needs to go, well, before it went 2.5 boxes, half of one 5-box section. So now it should go a whole 5-box section. It should go to right about here. Oh, wait, but not here. I almost messed up. It needs to be twice as wide now. So it's going to be here instead. And then where it came back to the original line was one 5-box section down. So I'm doubling everything now. So it should be 2 5-box sections down, which is going to be here, right in the middle, right? Right in the middle of this up and down. And now let me draw it. It's going to go all the way up here and then come back, boom. And then the last thing was this leg that went from that point that I just connected all the way down to the bottom right corner, which in this case is here, because it's twice as tall and twice as wide. And now I just connect. Notice I'm not even using my ruler. Like I'm trying to make things look pretty neat, but I'm not being like a perfectionist with a ruler. That's okay for right now, as long as it looks neat enough. And so this R is exactly twice as tall and twice as wide as this, as the original R. And so we would say it has a scale factor of 2. It's 2 times bigger. All right, so if you do 4 letters of your name like this one, like using one section like this here and here, like for me, I would do a like kind of a tall skinny O, and then I would do a B. Then you could make those all twice as tall and twice as wide using these 4 sections. See how you could do one letter here, right, and then another letter in here, and then another letter in here, and then one more letter here. And you would have just enough to do 4 letters in that way if you did them all like this. So if you want to do more work than that, if you have something fancier or more challenging or more intricate that you want to do because you're into it, go for it. But this is sort of like the easiest way to just get the minimum expectation done. All right, see you next time.